Hi guys, I'm Mrs. Richards. I'm sorry that I am missing the first couple days of school this year. Unfortunately, they found a couple spots of cancer on my lungs and I have to go get those removed. Hopefully, I'll be back by Thursday. If not Thursday, hopefully next week. So while I'm gone, hopefully you've gone over the syllabus already. And today, what I'm going to do is just do a quick little review with you of some of the things you learned last year. And hopefully we can get those math brains working here. And then when I get back, we will hit the ground running. Okay, so today what we're going to talk about is adding and subtracting integers. And I'm going to give you just a brief explanation. Some of you may have seen something called the chip method before. It's where you draw a picture, and some of you may not have. So it might help you out to know it, or if you know how to do it without it, you can do that as well. But at least follow along with the notes and fill in what I fill in, because I'll be giving you points for filling that part out the way I have it. And then the other side, you can do however you feel best doing it. Okay, so let's get started. I'm going to turn this around and I can bring up our note page. That's my computer. Hold on. Here we go. Let's move that over. All right. Ooh, this desk might be too small for this. Sorry, guys. Technical difficulties, but nothing we can't fix. All right, let's zoom that in. Okay, so again, I'm going to write this stuff in, and I'm going to give you points for writing what I write. So, first of all, put your first and last name up in the upper right-hand corner so I know who to give points to. And let's talk about it. So, you might remember this, but an integer is a positive or negative whole number. Okay, so any positive or negative whole number is an integer. You can't have fractions or decimals or anything like that. They got to be whole numbers. All right. Ooh. Okay, so that's what an integer is, positive and negative whole number. And something that some teachers talk about in using positive and negative whole numbers are zero pairs, okay? So all a zero pair is, I'll give you an example. A zero pair is like -5 and and +5. They're a zero pair because when you add them together, they get 0, all right? A zero pair is any set of numbers that are the same, that are opposite, and you add them together and they will give you 0, okay? So 2 numbers that add to 0. Okay, now when we do this, it's called a chip model. What we're going to represent them as, all the positives will make a positive chip, like a bingo chip, and all negatives, we make a negative chip. All right, and I'm just going to show you this because it might help some of you, and you might need an extra sheet of paper to write some of this down if you're going to use this model. And I have lined paper on the side counter if you need it. So I'm going to show you on this handy dandy graph paper that I've got, just because it's fun and I like graph paper. All right, so here's the chip model. Let's say you have -5 plus -8. And so this gets confusing because there's all kinds of rules with integers, okay? So with the chip model, what you would do is you would say, okay, I have 5 negatives, so I'm going to do 5 negative chips. Okay, and then I'm adding 8 negatives, so underneath that I would do 8 negative chips. So there's 5, 6, 7, 8. Okay, and then the question that you ask yourself first is, how many 0 pairs are there? So remember, a 0 pair has to be a positive and a negative chip, and those will cancel out. So in this case, since there are no positive chips, there are no zero pairs. There's none. Okay, and if there are no zero pairs, that means none of these cancel out. And so what we do is we add them all up, right? So we have 5 chips here plus another 8 here. That gives us 13 chips total, right? And they're all negative. So our answer is negative 13. And so that's a model that you can use. Now, some of you look at this and go, oh, -5 plus -8, they're both negative, so I know I have to add that, and it's going to be negative 13. If you can do that, awesome. But I just want to show people that maybe have forgotten. So let's try again. Let's try the next one. 9, positive 9 plus negative 16. So again, if we use the chip model here, right? I'm going to move my paper over. All right. Positive 9, so I'm going to draw 9 positive chips. 2, 3, 4. Wow, I'm not doing a very good job with spacing here. 5, 6, 7, 8, 9. And 16 negatives, which is a little annoying to draw, but it is what it is. And I probably used up way too much space here. So hopefully we'll fit it on screen. Anyway, here's 9 of them we know for sure, right? And then 10, 11, 12, 13, 14, 15, 16. Oh my gosh, can't even fit it. Okay. But now, let me back this up, back it up. So in this case, how many zero pairs do we have? So if you look, this is a zero pair, and the reason we line it up is it's easy to see, right? 0 pairs, 0 pairs, 0 pair. How many are there total? Well, and you can cross them out as we go. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. That means those do not get added up in our final answer. So what are we left with? Our 1, 2, 3, 4, 5, 6, 7 chips, right? 7 of them, and they are negative. So how many zero pairs did we have? We had 9 zero pairs, if you count those. And what we're left with is 7 chips, and they are all negative. That's our answer. Okay, and so for some people, they look at that and go, oh, 9 positives, and then I have 16 negatives, right? So I actually subtract here, and then I get a -7. And you can do that too. It's okay. All right, let's try again, especially for those of you that struggle with this, right? So right away, now, before I even draw anything, I have 21 negatives, right? And I have 8 more negatives. So if I'm going to draw this out, I'm going to end up drawing 21 negatives and then underneath 8 negatives. Is that going to give me any that cancel out? And the answer is no, because see how there are no positives there at all? That means that I would draw all of this out and there would be no positives to cancel out at all. So right away, we know that there are no zero pairs here. There's going to be none. So the trick is if you know there are no zero pairs in integers, you add these two numbers, so 21 plus 8, right? And you know that all you're drawing is going to be negative. Well, 21 plus 8 is 29. And then we know they're all negative. All the chips would be negative. Our answer is -29. Because do we want you to draw this out for every single one? No, the idea is we want you to get the pattern and be able to do it in your head eventually. But if you have to draw it, then draw it. Okay, let's do it again. -13 plus 18. Actually, you try it. You try it a second and see if you can come up with the answer without my help. And then I will show you. I'm going to do it over to the side. And then I'll put the answer up for those of you that need it. Okay. All right. And I'm going to draw mine so that those of you that need the visual, you can get it. All right. I'm still drawing mine. So this is why you want to get used to not drawing them eventually, because yeah, it really takes some time when you're doing a drawing for every single one, especially if we have a lot of them. Woo! I finally did my drawing. So let's see. How many 0 pairs do we get? Well, let's look at my crazy drawing here. If I do this, right, I drew them out, right, negative 13 plus positive 18, I end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? And some of you can kind of picture that in your head, right? If they are opposites, 13 of those, the lower number, are the number that's going to cancel out. So there's 13 0 pairs, leaving us left with, right, 5 left here, and there are positives that are left. And that's our answer. Cool. All right, so adding, yes. Can you use this method? Absolutely, if you're unsure. Let's remind us what we do with subtraction. So subtraction, some of you may know this saying and some of you might not, but what we really want to do is we want to make any subtraction problem with integers an addition problem. And the way we do that is use this saying: keep, change, switch. Okay? And so what that means is each piece, right? So the first number, we're going to keep that number. So we're going to keep the negative 5. So when I write it down, I'm going to keep that a negative 5. I'm going to change whatever sign is in the middle. So instead of that minus, I'm going to change that to a plus. And then I'm going to switch the sign of the last number. So the sign here was a negative. I'm going to switch that to a positive. And now I have an addition problem, right? And so now we go back to our rules up here. So if I line up 5 negatives and then 8 positives underneath, okay? And so you can draw it if you want. Again, this one's a little easier because it's less, right? So 1, 2, 3, 4, 5 negatives. And then under that, I put 8 positives. Some of you can already see what's about to happen here. How many 0 pairs do we end up with? In this case, right, if you look, we end up with 5 0 pairs. Is it a coincidence that that's the lower number? No. The number of 0 pairs here is always going to be the lower number. And our final answer then, if I cross those out, I'm left with 3 positives. Okay? All right, again, so I tried to include all the ones that, even when they look weird, okay? So again, we're going to keep the 9. Whatever that first number is, whether it's positive or negative, you keep it. No matter what, keep it. You're going to change whatever sign is in the middle. So we're going to change that. The idea is to make it a plus every time. And we're going to switch whatever the last sign is of that number. So this one, we're going to switch to a positive. Well, now I have 9, positive 9, plus 16. If I write out 9 positives, and then underneath it 16 more positives, am I going to have any 0 pairs? The answer is none here, right? Remember, if they're both the same sign, you're not going to have any 0 pairs. And now this we learned in elementary school. What is 9 plus 16? And you can use your fingers if you need to. If you add it up, what'd you get? 25 should be your correct answer. Okay, 2 more and then you're on your own. Okay, so what do? Look at this problem. Negative 21. Do we ever change the first one? No. We keep it. Keep negative 21. Okay. We change. We're always changing that minus to a plus. And then we switch the last one, whatever that sign is. So I have negative 21 plus 8. So I have 21 negatives, 8 positives, okay? And so You can line that up if you want to, but since these are different, right? How many 0 pairs am I going to end up with? It's not none because they're different. It's the lower number. So I'm going to end up with 8 0 pairs there. There are the 8 that are going to cancel out. So that tells me, right, if I have 0 pairs, that what I'm really going to do is I'm going to subtract. So 21 minus 8 gives us what? Gives us 13. Now, how do I know if it's going to be negatives that are left or positives, right? So picture that in your head. Am I going to have more negatives lined up or more positives? I'm going to have more negatives. So my answer will be negative 13. Okay, last one. Here we go. We're going to change it to an addition problem. Okay, so here we go. We're going to keep it. So keep negative 13. Do not change that. Change that middle minus sign to a plus. Now, plus, now I just have 18. Notice there's not a negative in front of that, right? So I'm going to switch that 18. This is where students get confused, to a negative 18. I keep the negative 13. I change the minus to a plus, and I'm switching this 18, which was positive, right? Keep it. That one's done. Change it. That one's gone. So I have to switch that positive 18 to a negative 18. Okay, how many 0 pairs? Well, they're both negatives. I would end up lining up 13 negatives and then 18 more negatives. Will any cancel out? The answer is no. So we have no 0 pairs, right? And if we have no 0 pairs, we don't subtract, we add them all up. So 13 plus 18 is going to give us how much? 31. Now, are they all going to be positive or are they all going to be negative? They're all going to be negative. And that's our answer. Okay, hopefully this helps you out. If you need extra paper to do the chip method like I showed you here, you can. The assignment is on the back, okay? We have this to do today right here. And then there also should be a math survey today, and it's all about you and how you feel toward math. And I will collect these and give you points for all of this when I return. Have a great day.